Yeah.
And what are
All right, good afternoon, everybody. So I'm guessing everybody is here already. You know any of your friends that is not inside, you can just give them a call. We're starting right now. So how was Python programming today? Is Python hard? Who said yes? Is Python hard or is it simple? Is it simple? Were you able to get the concept? All right, so I'm just going to walk through that. Just like I said yesterday, don't let it end in the class. When you go home today, you can do what? You can do what? Practice, yeah. Yesterday I said you can do video. Make sure you don't sleep tonight. Okay, so we're playing with Jupyter notebook until it becomes your friend. Is that okay? Yeah, so far we've seen an introduction to computer design. And I believe you know that where that fits in the robotic system development process. We've seen programming, I believe you know where that also fits in. So now the last time I was telling you that we're going to be interfacing software with hardware. Do you remember that? So now that is what we're going to do. We want to see how can we interface our software with our hardware. Is that interesting? All right, so yesterday I was talking about the processing units, the different computers our robots use. And today we are trying to work with one of those controllers or one of those computers. All right, those computers are responsible for interfacing our software with the hardware. So that's exactly what we're going to. So the same Python language I've been writing so far, the same language that you're going to be using to communicate with the computer for it to interface with the hardware. Are you following me? So that's exactly what we're going into now. So specifically, you're going to be using the controller or the microcontroller that we call the Raspberry Pi people. Someone say Raspberry Pi people. Last time I was talking to someone, he says Raspberry Pi is fruit. So the Raspberry Pi you're dealing with is not the fruit Raspberry Pi, okay? It's actually a microcontroller. So what's the name of the microcontroller again? The Raspberry Pi people, that's the complete name, alright? So I'm going to be introducing the instructor, the person of this man is a guru in the electronics, the wiring, the signals, everything is connected and voltage, everything is a guru. So welcome with me, Mr. I should be calling you. I should have different titles for you as well. All right, let's welcome Engineer Fajimi David. Yeah, hey, can you put that? All right, so I'm handing over to Mr. Davis now. Let's begin the session.
All right, good afternoon, class. I'm sorry, I might speak too fast for some people, but please just bear with me. This is going to be a class where we'll learn to interface our codes with the codes we write in Python with the microcontroller that we have on the table. Can everyone acknowledge that we have this on our table? To use this, you will need a micro C cable. Every group should please have a micro C cable with them. Normal 100 cable, regular 100 cable, please. We didn't provide it, but somebody in your group should at least have one. Does everyone have a micro C cable to connect to this? Like 100 cable, does everyone have an 100 cable to connect to this? All right, that's just what I want to figure out. Please also, did everyone download the zip file sent to the Google Drive yesterday? And how many of us have installed Tony yet? Tony? In your group? Who hasn't installed Tony? If you don't have the setup, let's know.
If you need to install Tony and you want to install Tony, please raise up your hand so that someone can talk about it. However, we are going to go ahead, but I don't want us to waste time like we did earlier this morning. So it's going to start the class. If someone else has it in your group, work closely with that person while you are setting up your own Tony. Is that okay? So the class is going to go ahead right now. So if you need help installing Tony, please keep your hands up and then you're going to get help.
You just need one person in the group. You just need one person in the group because everybody cannot be moving it and plugging it right. You get.
I'll tell them to assign someone in the group that will feature the connection.
All right. So everyone can just have one computer in each group that has Tony, and we'll work with that. All of you work together on one computer. Is that fine? Can all of you work together on one computer?
All of them can program on their computer, and then maybe they can put that code. Not like everybody, but all of them can program on their computer. All of them, everybody that has to should be programming, and then maybe if someone tests with the people, the next exercise, someone else should do it. The next exercise, someone else should do it. That everybody's able to approve. So it's only one person having to go for a single exercise, and then after the exercise, the next person. But as many people that have to, they should be able to do it.
Okay. So yesterday we learned that there are things we call microcontrollers. Yeah. Do we remember microcontrollers? Please, I need the response. Yes. A microcontroller. And what did we say microcontroller is? We said it's the brain of our robot. Yes. Now we have different types of microcontrollers. We'll be specializing in Pico.
Show your screen.
We'll be specializing in Pico, Raspberry Pico, but doesn't mean that there are no others. We have Arduino Uno, we have Nano, we have ESP, depending on your particular your personal choice. Essentially, the reason why we are using Pico is because if you look up at the screen, you see the features that Pico can handle. While this board is not very strong physically or voltage-wise or current-wise, it has features that old boards like Arduino want to have. It can handle up to 2 MB flash memory. It has an inbuilt Wi-Fi. It can handle low energy Bluetooth connections. It has an operating voltage of 1.8 to 5.5, and then you can code it in either C, C++, or Python. And we'll be using the Python that you guys learned today to code this Raspberry Pico. But before we use our Pico, There are pins on this pico. Can we see the pins? The pinouts on the pico. You can see the pinouts. If you look at the under part of it, check it. Then you will see the labeling of the pins under it. Can we see it? Can we see it? The labeling of the pins under the pico. Can we see it? The labeling. You can see VBOS, VSYS, GND, GP0, GP1, and the rest. Can we see it? This group, please, can we see it? Now, every of these pins has its own functions. All right, so the pinouts on this pico are labeled under the pico, are labeled under the controller. We'll be referring to them as the class goes on. Now we can see VBOS. The red side of our pinout, you can see VBOS, VSYS, 3.3 volts out. They are the voltage aspects of the controller. The VBOS has the ability to give out 5 volts. The V6 has the ability to take in 5 volts. And the 3.3 volts has the ability to give out the maximum of 3.3 volts, depending on the type of sensor you want to use. So we'll be referencing each of these voltages depending on the sensors that we have on the table. The GP pins are the input pins. You can either send in signal or get signal from them. Those are your GP pins, GP0 down to GP28. Now, some of these GP pins are multifunctional pins. We have some pins that can perform. We have some pins that can perform ADC. What we mean by ADC is analog to digital conversion. That means I can get an analog input and convert that analog value to a digital value so that I can use the value to perform certain functions. Some of these pins are I2Cs. It means inter-integrated connections. It's a type of communication protocol, more like your USB. And then we have some pins that perform SPI. It's called serial peripheral interface. And then we have some pins that perform PWM, pulse width modulation. Later in this class, we'll be going through all these pins and we'll be seeing their functions. Now, another pin that is very, very important is your ground pin. GND, that is your ground pin. That is like your negative. Where your voltage is positive, your ground is negative. So, to continue, can everybody please plug in their pico to their system? Their pico to their system, please. Everybody with USB cable. Just pick one person in the group for now. How many of our, when you plug it in, how many of our controllers brought out this interface? If it is not showing this interface, hold down the button on the controller and then plug it in. Hold down the button on the controller before you plug it in. All of us is showing? Nice. I want that pressure because it's true. Come on. New share. Okay. Is it content of second camera? I can't show at that point again. I won't be able to show screen if I share the camera. I don't know why. Maybe just come and check it.
You want to share the camera? Okay, because of what you are doing here.
Yes.
I think they will need to bring somebody closer to you actually. They will need to bring somebody.
Then in the zip file that we uploaded to the Google Drive yesterday, how many of the, does anyone in the group have it? The Google Drive. You should see this file inside, MicroPython firmware. MicroPython firmware. Can we see it? This file, MicroPython firmware. Does everyone have it? Every group. Now drag that file into that interface that was prompted. Drag it into the Pico. You didn't see it. You hold down the button on the Pico, then plug it in. What is inside the Google Drive file? RPI people, yeah, use that. Okay, this is what you have. This is what you have here. This is what you have. So into that interface that was prompted, drag that RPI pico into it. Once it copies, the prompt will close automatically. Have you gotten to that stage? Your prompt should close automatically. Have you all done that? Hold down the boot select, the button on the controller, then plug it into the system. A prompt should come up. Has every group done that? Okay. Yours just prompted. All right. Fit. Let me attend to them again. You guys have done it, eh? You guys have done that. Maybe you guys should use just one PC for now. All right. Okay, you guys have done that. You guys have done that. Thank you. Sorry. Environments, please, let's launch it. Let's come to these environments, please. Please, let's launch our Tony environment. Have you launched it? Have you launched it? If your Pico is set up correctly, you should have an interface on this side. Can we see a Raspberry Pico file explorer on that side? Right here. If you don't have it, click on this button here and click MicroPython Raspberry Pico. A prompt will come up on this side. Can we see it? Huh? If you cannot see this interface, yeah, okay. Click view. View, click files. On that side. If you don't have this side of Tony, go to view and click files. If you don't have this, if you can't see this side, this file explorer side of Tony, go to view and click files. Can we see this file explorer? Can we also see this file explorer? All right. Can you see Raspberry Pico underneath the file explorer? Everybody? If you can't see Raspberry Pico, come to this place and click your board. Raspberry Pi Pico. Have you seen it? All right, so this has launched our Pico environment. If I run a print function, try running the print function on this your shell repair and see whether it works. If it does not work, it means your Pico is not set up correctly. Run a print function on your shell repair. Just if it does not print, it means your Pico is not working. Have you tested it? Yes. All right. Okay, what is new? Okay, close it, Tony. Let's open it again. Launch it again. I'll check for this. All right. So let's do another quick test on our Pico. We can see on our Raspberry Pico there is an LED on it. Can we see the LED on our Pico? There is a small light. There's a small light on our Pico board. Can we all see it? Can we all see it? A small light on our Pico board. Light. A small LED. It's labeled LED. Yeah, let's quickly blink that LED. Now to run controllers on Python, there is a library in Python. There is a default library in Python called machines. And from that machines, we are picking a function called pin. Pin signifies every port you have on that controller. Pin, what pin number is it? Every pin number that was assigned to every pin on that controller. So I'll be calling that library and I'll be importing pin. From machine, import pin. There's a default library. Machine, we are calling the function pin. We are calling the function pin. Then also import time. That's also PCBs. Also import time. Okay, I did try. Let's try it again. Has everybody got to that point? Import time also. No, not from machine. Just import time. The time library is to help us set time for everything we are going to do. Meaning, if I want to delay a particular event, okay, I can set it to hold for probably 2 seconds. I can tell my LED to blink for 1 second, go off for another 1 second, come on again to set delays. That is the function of the time library. Okay. You guys, I don't want to quickly move so that because of you guys. You guys don't. These are you guys don't. You guys are completely set up. Can I continue? Can I continue?
He has already dragged this one from
All right, so please, wait, don't say them. All right, since everybody's up to speed, now let's create a variable called blinkLED. A variable called blinkLED. Remember I said we are importing pin from a library called machine. Now, the function pin takes 2 arguments. It means it takes the pin number and then what type of pin it is. Usually we have different types of inputs. You can have a pin to send signal out. You can dedicate a pin to send signal in. You can dedicate pins for ADCs. You can dedicate pins for PWM. Meaning, so that means if I want my LED to come on, I want to send a signal to the LED to go on. That means I'm sending signal from the Pico to something else. I'm sending out. That is why I have called the LED and pin out. The reason why I'm calling it LED is because the LED does not have a dedicated pin on the Pico. If I wanted to call a pin, if I wanted to call pin 1, I will do pin 1, pin out instead of LED. But because the LED does not have a particular pin on the Pico, that is why we are calling LED, and the Pico understands what it is. So pin out. Let's create the variable blink LED and send the pin out. Have you done that? All right, so we want to take our blink LED. So I want to take our blink LED. I want to make it high. This means go on. You want to plug in your Pico and click run. Have you all run it? Blink LED high. Once you click run, the light on your Pico should come on. The variable blink LED.I means we are sending an I signal, 5 volts, an I signal, 5 volts to the Pico. Blink LED.I. This is run. Can we see run? Run it. Did the light of your Pico come on? All right, did you run? Did your lights come on? All right, are we done that? Are we all done that? All right, now add another statement, and let's call it low. But before then, let us put a time delay in between the high and the low. Now you can see I called from time library. I called the sleep function. This sleep function has an endpoint, ms. Ms means milliseconds. So that means if I want to sleep, I want to delay this statement. I want to delay it for 1 second and then write the line low. Run it again. Let's see if your light blinks for 1 second and then goes off. If you run it again, and that happens only once, yes? It happens only once. Now, if you want to run this code infinitely, you have to introduce something called the while true loop. So while true, and then you want to press tab on the functions under. And then you call your delay again. So I want it to go high once, go low, wait for 1 second, go low again, and wait for 1 second. Run this code, your LED should blink infinitely. If you run this code, your LED should blink infinitely. Abi? Yeah? Do we have that? Do we have that? Is our LED blinking? Is our LED blinking? Is our LED blinking? Right. So is our LED blinking? All right, so let us do something that you guys did in the morning. It's not blinking. Connection lost. Stop. Click stop on the top there. Yeah, that's stop. Yeah. Run it again.
Yes. Yes.
All right, so let's do something that you guys did in the morning. Let us count how many times the LED is blinking. You guys, your tutor taught you something like increment, yes? Yes. Now, let us create a function n here. Say n is equal to 0. Now, for every time that the LED blinks, I want to print n. All right, you guys should do that. Print n and let n increase every time it goes through the loop. You guys should print n, please. Can you guys see that? I just gave you the cheat code though. Or you have n equals to n plus 1. Sorry, equals to n plus 1. Then we print, let's print our n. Yeah. Do you have that? Run your code again. Can you see? Let us print or switch how many times on your shell repair? Can you see the output? Run the code. You should have that output. You should have that output on your. You should have something like that. You should have something like that. I think that's done. Yeah, so you see this, I call it what do I used to call it? You know, I call it serial monitor. It helps you to understand what is going on in your people currently before you actually deploy your programs fully. So you know the state of all your sensors, you know the state of all your pins before you do anything, before you finalize anything. So that way you can monitor the variables and every other report. So I ran a string, I put the value of n, and I ran another string. So, and by now you guys will understand that the way Python interprets a program, it interprets it line by line. Once it gets from the beginning, from line 1, it goes down to line 11. But then we have a while true. Then it goes back to the while true. It brings everything down. It runs everything again. It goes back up. That is why you can have an increment like that. Because Python runs line by line. So further on, we'll see how everything we are going to be doing is going to operate. Now, you guys have an LED on your table, yes? You all have an LED on your table. LED. Sorry, light bulb. Light bulb. You all have it on your table. Now we are going to be blinking with that same code. We are going to be blinking this LED. I'm going to be blinking this LED. But before that, I have to introduce you to the connection of the breadboard on your table. Do you have this breadboard? Now, this breadboard was connected in such a way that, sorry. Now, this breadboard was connected in such a way that all the pins up here are connected together. all the pins on this row up are connected together. All the pins on this row down are connected together. And then all the pins on this column here, down this way, except it has a demarcation here. Just from here to here, and then from here to here is also connected together. This and this is not connected. This place and this place is not connected. So there is a demarcation in between. So you have 1, 2, 3, 4, 5 connected together, and then 1, 2, 3, 4, 5 connected together. So we have to learn our proper breadboard usage. Meaning that if I want to connect my LED, you understand that our LED has both positive and negative, yes? Meaning that if I want to connect my LED, I cannot connect my LED like this because you have short-circuited the LED, Abi? And I cannot connect it like this, yes? Because it's connected together. So if I want to connect my LED, I will connect it on 2 points that are not connected together. Do we understand that? So that way I can take an input, I can give one signal, and I can give the second one ground. Do we understand that? Now, on our LED, we can see that one leg is longer than the other one. One leg is longer than the other one. The longer side is your positive. The longer side is your positive. The shorter one is your ground. The shorter one is your ground. So this is how your connection should look like. The longer side, make sure you are not connecting this like this. Now, God, I say, beg you, make something no fry. Now, this is all these rows up here are connected together. All these rows down here are connected together. Meaning, if I want to plug in my LED that has both positive and negative, I can't connect this like this because I just joined positive and negative together. Then all these rows from here, 1, 2, 3, 4, 5, they are connected together. Then there's a demarcation here. Then this one's two are also connected together. So meaning, if I want to connect my LED now, I can connect this like this because I have positive on one rail and negative on another rail. That's what I just explained. So please, let's connect our LEDs. We all have jumper cables on our table here. We have wire on our table. Shall we all have wire on our table? Jumper cables, jumper cables. Now pick your Pico. Take your Pico. Select any GPO, any GPI pin on your Pico. Any pin that starts with GP, except the ones that have A at the back. It's literally almost everything. The A's are very few. Just pick any pin that you like. Pick any pin that you like. Any GPIO pin that you like. Personally, I picked GPIO 1. You will connect that GPIO 1 to the positive of your LED. You connect GPIO 1 to the positive of your LED. And if I connect it to the... Do you know how to connect it to the positive of LED? Now, this is GPIO 0. This is, look up everybody. Look up everybody. This is GPIO 0. This is the long side of my LED. If I connect GPIO 0 to any other rail here, it means GPIO 0 and the positive is connected together. Do we understand? You know, I said that everything here is connected together, yes? Have you all done that? Have we done that, yo? Just pick one, any pin that you like. Any pin that you like. Pick any pin that you like. Now, look up everybody. I go again. This is GPIO 0 on your Pico. Yes? If I connect my GPIO 0 with wire to any rail on this point, it means that the positive is connected to that pin. Remember what I said? Every port on this rail is connected together, yes? On this column. From here to here are connected this way. From here to here are connected this way. So that means if I connect GPIO 0 to anything here, it means that it is connected. Yes? So if whether I plug it here or here or here, it means that it's connected to this point. Do we get it? Do we get it? And then you will pick your ground. No. Look for ground, GNG on your Pico. GNG. It's called ground. Connected. Are we all connected? Now go back to your code. The pin that you selected, type it here. The pin number that you selected, type it there. I selected 1. Me that selected 1. The pin number that you select, just type it there. I'm sorry, the Pico is labeled funny. The first 3 digits, the first 3 labeling is for the first 3 pins on top. Have you all done that? The GP pin that is selected. Yeah, that is selected. Yeah. The GP pin that is selected. Just type the number there. The GP pin that is selected. That is okay. So that GND is for this first one. The GP1 is for the second one. The GP2 is for the third one. This is you have 0, 1. This is 0, 1, GND 2. Do we get it? Because there's no space, that's why they label this way. This GP0 is for this first place. GP1 is for the second. GND is for this place. Do we get it? Do we get it? Have you all selected our pins? You guys have finished it. Okay, yeah, I do. Then run the code. Your external LED should blink, please. If you run the code, your external LED should blink. If your LED is not blinking, you have If your LED is not blinking, I don't tell them. No. The longer side of your LED is your positive. Oh. The longer side of your LED is your positive. All right, so there are 2 extra LEDs on your table. I want every group to blink 3 LEDs not at the same time. Blink the blue, blink the red, and blink the last color at different times. And let's see how it's going to work. You have 3 LEDs on your table. Plug in the 3 LEDs, blink let your code blink the red, let it blink the blue, and let it blink the last one. Any color that you have, use any color that you have. The longer side of the LED is your positive. That is what you connect to your GPIO pin. The shorter side is connected to your ground. The shorter side is connected to your ground. All right, I believe all of you can do that, yes? Now, I know you guys will be thinking, your GND, you can have a common ground for your LEDs. That means you can tap ground from the ground you tapped before, and you tap it to the remaining LEDs. You can have a common ground for all your LEDs. You can tap ground from the ground you have before. You guys connected it to the breadboard, yes? The ground side. Look up, everybody, please. Look up, everybody. This is where you connected your ground to, yes? For your second and third LEDs, you can tap ground from here to the ground of the other side. You can, if you connect a pin here, male to male wire. The wires that has 2 pins on the ends. If you connect it here, you can connect it to the ground of the second LED and the third LED. Do you understand? If this is one ground, also, while you are doing this, please, now God I say beg you, disconnect your Pico from your system. Disconnect your Pico from your system while you are doing the connection. Don't let your LED blink, I beg. Disconnect everything first. Don't connect your. No, yeah, no, this is not good. Blink. The exercise is make sure you are blinking the LEDs one after the other. Don't blink it at the same time. Don't blink it at the same time. If you connect it that way, everything will come up at the same time and will go off at the same time. So that means that every LED positive side will have its own GPIO pin. Every positive side of the LED will have its own GPIO pin. Have you all done that? How many of us have done our own? Please, you guys have like 7 minutes to finish up. You have like 7 minutes to complete it. And do not edit your code. So every side will have its own GPIO pin, okay? You can limit anything you want, so that you be able to identify the distance.
So what are you saying to do? They have one here.
Okay, now I want you to blink all the LEDs at different times. That means if this guy goes on, it will go off, then this guy will come on to go off, then the last one will come on and to go off. It means that every positive side of LED will have different GPIO pins. That means I'll blink every, maybe you call it blue LED, red LED, and white LED. Then I will eye it, I will know it, I will eye it, I will eye the second one, I will know it, I will eye the third one, and I will know it. Do we understand? Exactly. Do we understand?
So what? Okay, yeah. Connect another one.
Which person has done their own? Which group have done their own? All right, about the code. Hold on. About the code. You have 3 LEDs, yes? All of you have 3 LEDs. Let's call them. You can call them anything. Blue LED, green LED, white LED, any LED you have. I really do not care. Create 3 variables for them. And assign 3 different pins for them. Assign 3 pins for them. 3 different pins for them. That means every pin will go to every positive side of your LED. Now, listen to the instruction again. I want the blue LED to go on, then go off, go on for 1 second, go off for 1 second. Then the next LED that will come up should be the next LED. 1 second, off. Then the other one, 1 second, off. Then it should repeat. It does not matter.
End does not matter at all.
The end does not matter. The end does not matter actually. So okay, the green LED was switched off. Yeah, exactly. So you can have red LED, blue LED, and green LED. All of them. That is why I said it is line by line interpretation. It will get here first, off, get here on, off, then it will go back up again. Which group has done their own? One group has finished their own. Yeah, all of them are connected together. A group has finished their own. Please, let's be fast. A group has finished their own. Yeah, it's a classwork. You guys should do it. It's a classwork. I'm expecting you guys to do it. So run your exactly. Now for every so for every variable that I call, instead of blink LED I, it's going to be okay. You want your blue LED to go I for 1 second, then it should go off. Change that blink LED to I, change that blink to B. All right, come again. Yeah. All right, change to B. Then come down, then do the red LED, let it come on again, then let it go off. Then do you understand? Yes. So cases. Yeah, I also mentioned something. I think 26 is an analog pin. Check. Pin 26 has an A following it, probably like A0. Look, you guys can use it. Maybe use a pin different from that. You might have issues with that pin. Pick something that doesn't have A0 at the back here. Then update it here.
If I'm moving 26 to another number, what do you mean? 20.
All right, so check it. All right, so instead of you guys should probably do LED was printed, say B LED was printed was switched 1. So for your print statement, run B, yeah, run B LED. Does not matter, but just for show you get. Then change. Does not matter whether it's a comment, it's a string, to print it the way it is. Okay. Where's the loop for TLED? Where's the loop for TLED? Come down. Okay, all right, so run it. If your connection is right, you should have. The third one should come up. You probably put it in the wrong pin. Check very well. Your outlet, is it 16? Yeah, run it again. Stop it. Yeah, click that. Check your pins very well, please.
I'm
No, it does not matter. What is this? Ah, what is this? That's GND. Is this ground?
Yes.
Yeah. Okay. Let me see this port number. 16 should be your last one. 16 should be your last one. If it's not there, maybe the LED is faulty. Red. It's supposed to switch. It's actually seeing it. Probably the LED is faulty. Let me get another LED. Change the LED. Sorry. How many groups have completed theirs? You quickly step outside. I won't give some other people lead. Okay. Do you have extra lead? Yeah. Okay. One group like that. I think they are doing this. Right. All right. If your group has successfully completed their out, try to play with the delay a little bit. See how fast the LED is going to blink. Try to play with your delay a little bit. You can use 500, you can use 200, anything. Just play with your delay a little bit. Now remember, I said this thing is in milliseconds, yes? I remember I said this delay was in milliseconds, yes? That 1000 means 1 second. So if you go lower, you are going to, if you go half, if you go 500, you are going half a second. You understand? Just like that. Has every group performed their own? Can we continue? Sorry. Is that ground, sorry? Okay, run your project.
So blink 2, what's the name? What's the name? It's not from the connection.
What's not defined?
Blink
Okay.
green 2.
Blink green 2, yeah. All right, has any group performed their classwork? Yes. No worry, no worry. This is just the semi-class work. There's still one more class work coming. There's still one more class work coming. All right, so on your table as continuation, sorry. Now there's a button on your table. There's a small button on your table. There's a small button on your table, yes? Can everybody see button? I am continuing. No. You guys are done, yes? Did you have time to play with your GBA a little bit to see how fast the day is? Now, if you look at your button, everybody should take a look at their button. You will see you have 4 legs there, Abby. Now, 2 of the legs are connected together. Now you look at your leg. Look at your button. Look at the button on the TV. Legs that these 2 legs are connected together. These 2 legs are connected together. That means these 2 legs are connected together, and these 2 legs are connected together. So if I want to use my button, I have to pick one from here and one from the second side, or one from here and one from here, depending on your choice. These 2 legs are connected together, and these 2 legs are connected together. You can't pick this one and this one. You have to pick one here or one here, or you pick this one like this. You get these 2 are connected together. This is let's call it positive, negative. This side is positive, one side is negative. Button does not have polarity, but once you pick one side for positive, you cannot pick that same side for negative. Once you pick one side for positive, you can't pick that same side for negative. Do we get it? All right, so pick your side. Before you connect that button to your breadboard, connect it to a place on your breadboard. Preferably, you want to connect your button like this. Connect it across the bridge. Connect it. You know you're connecting it this way, yes? The 2 sides that are connected can stay on the same rail. And the 2 sides that are not connected, make sure that the 2 sides that are not connected, they are. The 2 sides that are connected, this can stay on the same rail. And the 2 sides, make sure the sides that are not connected are on different. Do we get it? Do we get it? You can see your button. Look at the legs. But you see these 2, you see that side where you have 2 pins coming out. Those 2 pins are connected to each other. These 2 pins are connected together. Yes. Meaning that this and this is connected, and this is connected. Okay. So that means I can only pick. Sorry, these 2 pins.
Just do it upside down.
This place that does not have pin. This place and this place is connected together. Okay. And then the second side too. This place and this place is connected together. So if I want to pick a pin, I have to pick one for positive, and I cannot pick the one I pick for positive. I have to pick another one for negative. That's so if you look at Let me zoom in on my phone. Can we see it? This place and this place is connected. This place and this place is connected. So you pick one from here and you pick one from here. Do we get it? Do we get it? If you don't understand, just look, this green stuff is your pins. Just use it as a reference. Now I want to connect one side of that button to another GPIO pin. Want to connect one side of that button to another GPIO pin. Let's quickly run something that you guys did if statements this morning now. If statements, yeah, we are going to use your if statements now. Do you get it?
This is stretched already, so you can just put it here. You stretch the diagonal already.
Look at it. You see these two pins? They are connected together. These two pins are also connected. So these two pins, sorry, are connected together. And then these two pins are also connected together. Meaning, if I pick this one for my positive, I cannot pick this one for my negative. I have to pick the second one for my negative. Button does not have polarity, but once you pick one side for the positive, you cannot pick that same side for the negative. That is why I said pick one side for positive and then pick the second side for negative. So when you are connecting it to your breadboard, you plug one to this point and one to the second point. Anyhow, do we get it? All right, so see, you're waiting for that. Now, this type of button is called the push button. Push button. And this kind of button is already connected together. That means it is when you push the button that is going to give out something called a state 0. That is off. This is when you push that button that is going to trigger off. And in that state, you have to ensure that your code is set to automatically high. There's something called floating state. There's something called floating state, meaning that if you don't have something connected to if you don't declare your pin, every pin that is not being used is floating between 0 and 1. Now, if you don't declare that, okay, when I don't push this button, it should be automatically high. It is just going to fluctuate between 0 and 1. Do we get it? Do we get it? That will bring us to something called pull-up. That will bring us something called pull-up. So in your code, your button for what? Button, let me call this button. Your pin number. Now, notice that you remember that I said if you are sending signal into your Pico, you have to set it as a pin-in function. You have to declare the pin-in this thing instead of pin out, since I am sending to my Pico. Then you also want to call it now, okay, this thing should be pull up. So automatically my Pico understands that the button is always high until I press it. That is when it goes to 0. Do we understand? All right, so let's run this. Let's do this code. Don't run it here to now. I say beg you.
This display is circuit for them.
Please ensure your connection is very correct before you do it. Now, God, I say beg you. Ensure your connection is very correct. Be very confident in your connection. I have something to smell. Shall I have something like this? Huh? Circuits, all right. Now let's print the value of the button. Yeah, that's correct. Circuit again. I beg, where you guys let me check the circuits, I beg. No, let me check their circuits, I beg. That's why I say beg you. This is the circuit. Once we run pull up, we want to check the state of our button every time before we run any other code.
Push button.
This is it. This side. These two on this side. Look at the reference. These two on this side are connected. That is why I picked one from this ray. These two on this side are connected. These two on this side are connected. That's why I picked one here, and the two that are also connected. Meaning that I can plug it. If I plug it this way, these two that are also automatically connected can stay on the same rail without any issues. But I can't plug this way because these two are not connected. If I plug it this way, I just breach the button. So that means that these two that are already connected can stay on the same rail.
Let me see the one that are connected.
These two.
Let me passport.
See, the wire goes like this. The wire inside goes like this. And it goes like this. Meaning that I can only pick one from this wire. So I can put one wire here and another. I can put one input here and another input here. That is what it means. But if I put it here like this, I'm just putting the two inputs on the same wire. Do you understand? So this since it is wires that are inside these rails and they are connected together. I can connect these wires that are already connected together. If I put them on the same rail, it does not matter. You get? It does not matter. But if you are feeling much comfortable with this, it's also fine because we are only using one leg. But I'm just saying it does not matter. As you guys should. Okay. So this is
You mean that all of the legs can enter
so yeah, all the legs can enter without issue. So that means I'm plugging one to this point and one to this point. That is positive and negative. Do you understand? Do you understand? That's good. Okay. So you pick the one from here. Yeah, that's correct. Yes, I have one small auxiliary breadboard somewhere. Here's one auxiliary breadboard. I have one small breadboard somewhere. Okay. Yeah, that's two connected. All right, are we all done with our connections? All right. So let's go back to our Tony. All right. Let's go back to our Tony. And let us run this code. Tony. Now, it is the, you know, I called it button, yes? Yes. It is that button value. We are calling another function. We want to print the value of that button. So you run your syntax like print button dot value. Print button dot value. So whatever is here is what you use here. Whatever is here is what you use here. Then run the code. Let us see. Print button dot value. Make sure you put your PIN number there. Make sure you put your PIN number there. I run the code. Let us see. What do you have? I didn't say leg for pull up. I said button for pull up.
What you see? This button now.
Yeah, you put your B leg for pull up also. You put your button for pull up also. It's not supposed to be.
That means you have to define this name.
Sir, is it like that?
You have two. You have two four. You can't call the same pin for both button and.
You see that it's not because of the
You can't call the same pin for both button and your leg. And make sure that your leg is not pull up. It is your button that is pull up. Look at what I wrote on the. Look at what I typed on the board. My leg is pin 1 and it is pin out. There is no pull up. My button is pin 2 and it is pin in, and then there is pull up. That button pin is the button pin, any GPIO pin that you select for your button is what it is.
Okay, but we use like normal.
You use what?
Like for this one, we already put it in GP4.
Yeah, you can use 4. But then don't let your leg be the same as your button. Meaning you have to switch one. This is Jerry. This is GP4, yes. This is GP4. Okay, give me. And this is GP4. Then this is positive or negative?
It is positive.
All right, let's connect it to another pin number. Connect it to another pin number. Then you connect your ground to. You can connect your ground to the same ground. It does not matter because these ones and these ones are connected. Yeah. This guy is connected. So I can connect my ground to the same way. You can now pick another GPIO pin for your positive side of your leg and make sure that your ground is also connected. Two GPIO.
I was like,
so another GPIO pin. Another GPIO pin. Pick anything you want. You pick 21. Then give here's the ground. Yeah, that is ground. Okay. Have we all gotten our circuits correctly? That is ground. Yeah. That's your positive, yes? That's your negative. Yes. You can also connect it to the negative of your. Yeah, you can. Hope it's not connected together. Then you still need to tap ground from you.
Another ground.
No, you're not tapping on that ground. No, this is just negatives connected together. You've never had ground before. You still need to get ground from this place. So this ground is connected to this ground for the LED. Do we get it? You guys did rubbish. It's supposed to be like this. The long side is your positive. The downside is your ground. So if this is ground, sorry, this is positive, then this is negative, yes. This is negative. Since I took my ground from here, I can also take my ground from here, but since it's also connected, I can also take my ground from here. So it does not really matter. So grounds are connected together like that. Do we get it? We get it? Yes. Anything on this way, but since we already bridged it already at this point, you can still also pick it from here to here. You have done it, have you? I'm coming. Yeah, press the button. Click the button. Click it. Is it clicking? Click it down. Should change states. I'm coming. I'll sort that. I'm coming.
We don't know what our P1 will do.
Okay, first, this is the longer side. Just leave your pin 1 for now. This is the longer side. Leave the longer side for now. Get your ground to the second side of your button. This is GPI watts. 11. And this is GPI. And this is ground, and this is ground. Should click. Let me give another button. I guess let me give another button. And there should be nothing wrong with the button. This is how it's supposed to work. Hold on, I'm coming. Something is wrong with this person. Faith, give me another button. First, this and this is connected. This and this is connected. Please give me multimeter. Yeah. So this is connected together, and this is connected together. It's working. So GPI, okay. Let me switch the GPI to 2 or 1, 0. And I put it on one end. And then my ground for another side. Right, let me switch this guy. That is 1 and ground. That is 0, GPI 0 and ground. So, what is wrong with this button? It is supposed to. Hold on. Okay. Come on. This. Stop. And this again. Oh, sorry. It works. It should work. Four. Button dot value. No, this is correct. Pin is undefined. What did you speak in? 0 pin dot pull up. Pin dot pull up. Ah. Sorry, pull up. I shared the one that was wrong. Pin dot pull up. No. So let me see. This is my ground. This something is wrong somewhere. Should go off. Okay. Let me sit down. So let me sit down. This point should also so it's not switching. There's something wrong with this button. So what's the switch? It should switch states. Let me get another button. Give me another button inside. Okay. Done. Think of this. This is this guy. Okay, switch back to pull up. This is not right. I'm supposed to have a switch of states. This is GND 01 GND. So the switch of states. This is that. Another delay kind of sleep. Let's sleep. That's I was also introduced a delay. It was too fast, so it was picking the values. But I did pick the values before I hit the stuff. Sorry. Introduce a delay to your code, please. Introduce a delay to your code also after you press the button. After you press the button. Actually, two. If your connection is correct, you should have a series of ones being printed if you run your code. The thing is, what is, even if you don't have the delay, if you run a LED blink for it and you press it, it's going to go off. It's just that the serial monitor is picking values without, you can't pick values that fast. That is why it's just clicking one. All right. Introduce a delay to your code, please. Time dot sleep. All right, press the button. You should have a switch state between. You should have a switch state between. You should have a switch state between 0 and 1. If you press the button, you should have 0. Introduce a delay first. All right, so let. Okay, this guy. I'm not using. It's not showing myself.
No, you are showing it to get this. So let's go to
Okay. It's not pressing.
yes, that's it. Go to that share everything, share everything, and share. This is what you want.
This is what I'm doing. Sure. All right, so introduce a delay. I had to introduce delay because serial monitor cannot pick distance very, very fast. So we can show one. If you press the button, it also shows 0. It's working, but like serial monitor cannot pick 0 once it is just printed. You know? So that's why. Let's quickly run this statement. Let's run if statement. Oh, if my button value this is what equals to mean in Python.
It's not working.
Okay, introduce a delay first.
Something is not really
The thing is, if you don't introduce a delay, this serial monitor cannot pick responses that fast. So if you don't put a delay, it will just print. It has printed this one since time passed. Before this, all these ones have been printed before you know it. As soon as you run the code, and it has printed like 1 million of it. So if you don't introduce a delay, it will just keep printing what it has already printed in time passed. So if you introduce that delay, you have more data responses. So if you run it again now, you see you have better values. Stop it, then run it again. Stop. Yeah, run it again. Yeah, press the button. Hold it down. You have hold it down. You see, if you hold it down, you see 0. You see, if you hold it down, make sure the button you're holding it down. So it is when you release it. Like I told you, the default state of the button is on. So that means you have to hold it down for it to go off. You get what I'm saying? So again, now I want to run an if statement. If the state of my button is 1, I want my LED to go off. All right, do we have this code? Do we have this code? Yes, if my button value is giving me 1, it should still be switched off. When I press the button, the LED should come on. Run it and see if you have that function. Sorry. I go finish 119, I guess. I go finish it. I still get this guy. And then we do the last one. Yeah. And then we do yeah. All right, how many people have done that? You guys have your own. You guys have. It's not working. Check your pin numbers very well. 5 and 7, have you?
7 is for the bottom and 5 is for the.
Where's your ground? This is ground, have you? So you tap ground from here to the second side. And you get this is correct. If this LED working, are you sure this LED is working? At least it should still also change state here. It should still also change state here. It's not changing state here. It's correct. Still also change state. Yeah. Yeah, it's off. You guys, you know, it's not changing state here also. If button dot value is equals to 1, that's what is there. Then send so, let me change this their button for them. But your code is right. And everybody, you guys are done. Did your own work? Did your group ones work? Eh? If you like say some, yeah, if you like say some, but wait, hold on. First, make sure once you get the value, try to get a delay because you have sometimes you have time loss. Because sometimes if you don't print the one for eternity before you even reach there.
Can you say printing 0 right now?
Yeah, it's still printing 0 already.
Okay, I'll put it down.
Let's go MS to the maybe 500 or something. Okay, the indentation is also bad. Yeah?
This guy is not going to. Huh?
Yeah.
They're not switching.
Yeah, some buttons. I don't know what's wrong with some buttons. Yeah, everybody have most they've done their own. Yeah. Sorry, it's like some buttons are not functioning well. I'll have that sorted for all of for groups that have done their own. You guys should please open this package. Water sensor, water sensor. Water sensor, please. First, this one are connected, yes. I pick from either side. This is GPIO 7. That is GPIO 7. And your ground is your ground. This is correct. That is correct. This is correct. Switch. Yeah. I didn't, yeah. Fits. Yeah?
Okay, this one works. Where's the concept of them?
I don't understand. All right, so every group have done the button function, yes? Every group have done, you've done your, yeah, sure. Open your water sensor. There's a cup on your table. You guys will look for water by yourself. Just a little. There's actually a water sensor and a relay on your table. I'm sorry. Yeah, any type of water. This is the last exercise we do for the day. Then tomorrow you guys will do a classwork on the last sensor on the table. You guys will do a classwork on this sensor before we start tomorrow. Everybody. PIR sensor. You are not changing group. All right. You can, if you look at your sensor, your red sensor, you can see a Y, a minus, a plus, and an S. Can you see it? Can everybody see it? Yes, sir. Your minus is your negative. Yes, sir. Your plus is your positive. Your S is your signal. Now, your plus is where you will get. You look at your. Remember when I said about your pins? Remember what I said about your pins? Your V bus, your V6, and your 3.3 volts. Your V bus has the ability to give out 5 volts. That is where you will tap for your plus. The V bus is where you will tap voltage, 5 volts for your plus. And then you will tap ground also to your minus. And then you will select any pin for your S, any GPIO pin for your S. So make sure you connect it this way. Make sure you connect it this way. If you look up, I connected from VBus to this place. That is 5 volts, and I connected ground to this place. So I connected all my positives to positive, and all my negative to negative. Do you understand what I did? Since everything here is connected, all my positives are going to here, and now since everything up on this place is also connected, all my grounds are going there. Do we get? Do you understand our breadboard connection? This pin on my Pico is called VBus. VBus, can you see VBus? Can you see VBus? And you can see ground here too, on the third pin here. Now, that VBus is supplying 5 volts. 5 volts. And if I put 5 volts to this place, it means that every rail here has 5 volts. So that means I can take 5 volts for my plus on any pin there, and I can take 5 volts from my relay on any pin there. So I can take all my 5 volts on that rail that I connect. Please, if you know you have issues, you can connect your positive here and your negative here. Anyhow you want to do it. Yeah, sorry, we could not get pump for everybody. Want to use the signal from our sensor to determine if there is water. If there is no water, we activate our pump. Sorry, there is no pump for everybody. Maybe all of you, but you just run the relay. All right, as everybody should run their connections, please. Do you guys understand this? You can guess this is okay. If your VBus is connected there, it means that your VBus is giving out 5 volts to every power on this wheel. So that means if I connect any pin from here to any positive, I have supplied 5 volts to it. Then my ground, if I connect to the second ground, it means that every rail on this second side also has ground, but just so that you will not do mistake. So that is ground. This is 5 volts. So if you want to tap 5 volts for your this thing, you plug it on the positive. And if I plug it to any pin here, 5 volts are already entered. You get it? So same thing for the ground, and you select any GPIO pin. Are we all done? Hold on. Wait. Let me see your don't connect normally open and common yet. Please. Don't connect normally open and common yet, please. Use the other side. VCC. You should see VCC, ground and in. Check the second side. Not the second side. Now for your relay module. Some groups are connecting their relay module. Your VCC is your 5 volts. Usually voltages is we denote them by, you can use plus, you can use VCC, you can use V, you can use 5 volts. Anyway, you see VCC, it means that you want to give it 5 volts or 3.3 volts.
So, classification of components. They asking me what's the name of this, what's the name of this, what's the name of this.
I'm sorry.
So I think
That's this is your water sensor. This is your relay module.
like this one
This component that is red is called your water sensor. This one is your one is probably a blue board. This is your relay module. Look at what I did. Everybody wants to get. Hold on. Everybody wants to have 5 volts. Where's your breadboard? Don't throw your breadboard away, okay? Okay, now I'm sending out 5 volts for my breadboard.
Yes.
So that I can connect every sensor to it. If I connect, that is plus or minus.
On this one, they don't like it now.
V-Boss gives out 5 volts.
Like you don't get what I did.
It's not on big boss.
It's not on V-Boss.
It's on V-Boss.
Okay, the first one is on
Oh, the first one is V-Boss. The second one is VC.
Labeling.
The third one is GND. Then the fourth one is now 3.3. It was because there was no space. That was probably why they did it this way.
You are right.
Okay, so then you can now pick 5 volts for your relay, and you can pick 5 volts for your sensor also. You get it?
So okay.
So
5 volts
since 5 volts comes out from here,
Yeah.
I can send 5 volts to here, and I can send 5 volts to S plus.
Okay, so that's where the
And I can send 5 volts to here too.
another 5 volts.
So
Okay,
so
get it.
so my GND too. This is
Ground.
GND. Yeah, this is GND.
that's GND.
I can get my ground to ground here, and I can get my ground to ground here too.
What if you want to attach the
Any-
pump? You want to attach the
Yeah, just to leave the pump for now. Let's. I've asked them to connect to V-Boss. V-Boss gives out 5 volts.
Have they connected the signal pin of their water sensor?
They've not connected signal pin to the water sensor. You will now select any GPIO pin for your signal pin of water sensor. Also connect. Let them connect their relay too.
Right, all right.
Any other group having issues with their connections? Hold on. Battery for what?
And also
Don't need battery. That's what I said. Your controller is already supplying you all the power you need. That is why we connected here to Didu. That is why we connected here to V-Boss. That means 5 volts is coming out from here. That means 5 volts is coming out from my V-Boss. So if I connect 5 volts, if I connect this guy to VCC, it is receiving 5 volts. And if I connect my plus here to the V-Boss too, this is plus. It's also tapping 5 volts. So any other side is also ground. Same thing with the ground. You tap your ground to the second side. So if I tap my negative down to ground, and then I'll tap my negative here to ground. Do we get it? So you don't need.
connected the signal to this one.
No. You're not supposed. Your signal is not going to. Both modules will have their own GPIO pins on the Pico. Look at both components, your relay and your sensor will have different GPIO pins. So from my sensor, I picked GPIO 1, and for my relay, I picked GPIO 0. You get? So the signals are not connected. You will pick. We are running 2 different signals because my sensor will send in and my relay will come out. You get? I want to read what my sensor is doing, and I want to give out an action to the relay. I think they need female to female. Please ask them. They will give you female to female. Question? Yeah. Any question? Sorry. Yeah.
Okay, so that battery. So are we like
The battery, your controller is supplying your voltage. This V-bus gives out 5 volts. Yeah, so 5 volts is already getting to your this guy and this guy. You get what I'm saying? So since this guy gives me 5 volts and I'm connecting my plus to 5 volts and I'm connecting my plus here too. So everybody is getting 5 volts. Yeah?
we have 5 volts already?
No, see, leave the battery for now. Let everybody ignore the battery for now.
What about
Let everybody ignore that first. Everybody should please just focus on these 3. Ignore battery for now. Focus on these 3. Ignore battery for now, please.
The signal from this side
It's going to any GPIO
any
pin.
GPIO pin.
And the in for that side is also going to any GPIO pin too. All right. So let's go to our Tony. Whatever pin you select for your sensor, let's call it water sensor and relay. My water sensor is getting a signal. Let's call it pin in. And I'm connecting it to pin. I'm connecting it to pin 1. And my relay is, I'm not running this guy. So I'm running pin out. Running pin out. Okay, so print my relay value. So print my relay value. So first, to test your water sensor, let's print the values of the water sensor out. Now, it is very important to know that different types of sensors gives out different types of signals. The water sensor only detects whether there is water or there is no water, meaning that it can go high or low. That is 1 and 0, just like your button. It is not giving out a very type of signal that deals with analog signals. It is either going high or low. Sorry. We have different types of signals generally. This is your digital signal. It can only be high, it can only be that 1 or 0. When you are dealing with analog signals tomorrow, you will understand what I mean. So your water sensor is a digital sensor. So once there is water, it will go high. Once there is no water, it will go low. The other types of sensors, the other types of signals too, but don't worry, as you guys go into this thing very well, you understand this thing. So your digital sensor is your discrete time signal. Your digital signal is your discrete time signal, and your analog signal is your continuous time signal. You also have deterministic, even periodic energy. All those ones are not for now. So now, when we are done with our connection, let's print the value for our water sensor. Let's print the value for our water sensor and run your code. Don't run any if statements with it. Run your code. You should be having 0. You should be having 0. If you have connected it correctly, if you run your code, you should be having 0. No, leave the delay first. Leave the delay first. I'm not using the delay yet. No, still click it. So click the second one. That's it. Yeah, run. Should having 0. If you're already having 0, try dip your sensor into water. It is supposed to change. If it is not changing, check your pin out. It is supposed to change. If it is not changing, you are wrong. If it is not changing, you are wrong. Check your signal pin. If it is not changing, you are wrong. Dip it inside water. Once you put the surface of this sensor inside water, it should change, your value should change to 1. Wait, hold on. What do you need?
Last one.
Okay, has it changed?
No, it's not changing. So walk down first. What's the signal?
This is your signal. This is your base. Okay, where's your ground? Where's your ground? Okay, this is your ground. The second one. That should. Let me remove this guys first. This is negative. This is ground. This is positive. And that should change. Your signal pin is 0. Not, is it 1 or 0? Okay, it is GPIO 1. Okay, GPIO 4. And it should be PE. You are sending in a variable. You are sending in. You are not getting out. You are sending signals. Okay, you want this guy to give. Plug it.
Please announce them not to dip this chip inside water. Only this place is blind.
Oh, sorry. Don't dip the entire sensor inside water. Just that surface. Just that line side only, please. Just that line side inside water. I beg, now God, I say beg you. All right, all our sensors working. All our sensors are working. Now let's use that reading to trigger our relay. Now you guys should remember something in the. If you guys remember something in the specifications, I said your relay, your Pico cannot handle anything greater than 5.5 volts. Remember, now, when it comes to some components, sometimes you'll have to trigger something that deals with 24 volts, 50 volts. This relay module here is what helps you isolate between 5 volts that your Pico can generate and an external source to power something else. So it's more like your relay is like an automatic switch. Your relay is like an automatic switch. So if I say, okay, once my signal to my relay goes high, turn something on. That is what my relay does. So I can use my relay to trigger something of 100 volts, 500 volts, as long as high as possible, as long as it meets the rating. That is why we use relay. So that naturally I can power if I can power my pump with my Pico, I will have just written it high automatically. But since I cannot do it, that's why I'm using a relay. So now let us run our relay. God, I am tired. I am tired. I will tell you. All right, so let's run our if statement. If my WS value if my WS value is what? If my value is 1, I do not want my relay to what? I do not want my relay to what? To switch on. So that means I want my relay to relay.low. That one means if it is seeing water. If my sensor is seeing water, I don't want my relay to trigger on. That is why we are using relay low. Low means don't come on. Else relay.high. That means I can incorporate this kind of system into a water tank. If I dip my sensor, if I place my sensor at the top of a tank, if water doesn't get to that top of sensor, the pump will not stop. So once water gets to the top of the sensor, once water touches the sensor, I can trigger my pump off automatically without me turning off my pump. So we are looking at system that can complete entire functions. All right, let's connect our relay. Is our relay connected? If your relay is connected, you can run your code. Your relay should, once you plug in your relay, you should hear a click. Please let me give them female to female. Huh?
Let's stop again. Let's go. Are you ready? Yes, boss. On your mark.
Run. You didn't put your relay.i and relay.low. Them are the parentheses.
Sorry. Make sure your code is correct, though. What they are calling functions, don't forget your parentheses after. Don't forget your parentheses after.
Are you ready? Are you ready?
It's empty. You are calling a function. You know, we've declared a variable up, and want to call that low function. So you have to put parentheses after. No, hold on. Before, don't put it inside yet. Clean it. Run your code. You should hear a click. Hold on. What's the value now?
0.
0? Yes. Put it inside water, let's see. Did it click? Did your relay click? The green. No, the green side of your relay should come on. The green side of your relay should come on. Check your signal of everything very well. You guys connect it very well, please. The green side of your relay should come on. Okay, is it? Okay. It's not changing. It's changing to 0, but it's not switching.
1. It's showing 1. Yeah, it's showing 1 when you say water for the PS value. For the relay is not changing.
No. That's 0. That's 1. Remove it. Oh, clean it. There's still water on the surface.
Yeah, that's the
It should be 0. Yeah.
Yes, but the relay.
Yeah, hold on. Relay should. Chain and low level relay. I beg, give me this relay. I beg, quickly borrow me. Chain and low level relay. Hold on, I'm coming. I'm coming. It's fine. Relay can stress somebody. Relay can stress person. Okay, give me female to female. There's no female to female. I need 30. I need 30. You do inside. Inside the bus.
page. Where's my blue page? Okay. What pin did I put it for? What pin did I put it in? Yeah, GPI pin.
Which one has the trace on it? Is that white?
Yeah, this is this there.
Okay, yeah, this is one.
That is GPI 2, yeah? Eh? No. Yeah, I'm coming. I want to check something. Yeah, this is the shape.
Who is it going to
Hold
run?
on. It's not switching. Oh. Hold on.
It's meant to come on once you connect to this.
Yeah? It's not, the thing is, it's low level trigger relay. So you are supposed to switch it off for it to come on. Even now, it's not switching. I'm coming. Yeah?
What about this? When it's connected to this, is it meant to turn on any of this LED?
Yeah, that's the thing. It's supposed to be off. I'm trying to figure it out.
I mean, I'm talking about the light. No, one ought to be off actually. One ought to be off actually. Whenever it's plugged in, normally one ought to be off.
One ought to
Whenever
be
it's
off.
switched,
Yeah.
Then when it's switched on, one of them, the other one comes
Yeah.
on. So most of them, no LEDs coming on for them.
I think both of them
That
don't like
if you know, if both of them is not coming on, then the ground and VCC has been mixed.
if normally like this, what should I put in is this? Both of them should be like that's because of the I think this is so that's one. So now if none of this is coming on the cloud, if both of them is coming
That is I. I want it to go low. That's good. Okay. You know, swear is no. Okay, no I. Drop it here, drop it there. I'm trying to see if it's clicking. It's clicking. To click here, I said. It's clicking. Give me that black relay on the table. You can't see this one at the level. You need to sync current, and this guy cannot sync to me. Brother Neil. It's on the table, black like this. You see the issue with low level trigger release is that once it has to sync current, and the current is not enough, and the people cannot find where to put it, it will not trigger. The LED will just be small. That's why you have more functionality with high trigger release, because it's the one that is giving it. So anything that I give it, this guy will take it without any issues. But once this guy cannot find where to sync it, it will not trigger off. That's the issue. That's what I don't know.
This is an high level trigger.
But we don't have many of this.
Alright, we have like two now, so we make use of that one. For a trigger, let me turn it up.
The leg will give you. This is why I like.
No, so that's Yeah, same thing.
Oh.
Now, low level
So
trigger shit.
this guy no get. He wants to sink more than this thing that this guy can sink.
Yeah,
So it's
that's
not.
like a limit of current. or
Yeah,
something.
like you don't limit the current. Bro, Daniel, come see.
Now, this killing game,
I
think we have to use
hate
it.
boards.
I use boards.
I hate blue boards. So this guy is voltage dependent. This guy is current dependent.
One droppers waiting to pay the supply.
No, you want put inside the pin, waiting the pin to pass, waiting.
Now, waiting at the
So he wants to put 50 milliamps, and this guy, the entire board na 50 milliamps. The entire board na 50 milliamps.
That's why it's kind of blinking.
So he just
Tell them because
I can explain.
but if you want to know the reason why
Hold
they
on,
already
I should have eye level trigger.
I mean, inside your
There should still be one more. Now you see this guy is clicking. See this guy. That is because this guy wants to give the people current than the people can handle, so the people will not collect it. But this guy is current dependent. This guy is voltage dependent. People will just give it 5 volts. Any amp plate, it will trigger. But this guy 5 volts, but he wants to give the people 50. He wants to give people current up to 75. And if people cannot handle it, it will not collect. People will not collect it. And the entire people is not designed for 50 million. So it will not collect it.
So people can handle
Only 50 million.
Like, how many of these are working the way up?
I think there's another relay on the
So
table.
you need to write this I to trigger it, right?
Yeah?
You need to write this I to trigger it.
Yeah, you need to write this.
You might need to show each group. Explain to them what the problem is.
Every group should please every group should come around one by one.
No, don't let them come around. Let them be seated.
Yeah, but like they have to see that it's working.
Yeah, you need to. I mean, you take it to them. They only how many groups?
All right.
Yeah, take it to them one by one.
All right.
Address this generally. So see what the challenge is.
Okay.
And what we're doing to fix it. Yeah? Let them what the problem is. Why is their people not working? And what are we going to fix?
Okay, so I want to run the rest too like that. Give me screwdriver. Yeah. Yeah. Give me screwdriver. Give me screwdriver. Yeah, so sorry, I'll be coming to each group one. Sorry, I'll be coming to each group one by one to fix your issues. Let me start from this. Sorry. I'll get everybody fast now. So there is a major issue with there are two types of relay modules essentially. There are ones with blue boards that we call them low level trigger relays. The ones they have been are called low level trigger relays. There are ones with black boards. Your blue boards are current dependent, meaning that it wants to take current. It takes current to trigger. But then your black boards are voltage dependent. If your controller cannot handle the amount of current that the relay is demanding, it will not trigger. It's not like it's not triggering. If you look at your LED very well, it will on small. It's trying to trigger, but your controller does not have the capacity to turn it on fully. That is why we have voltage dependent relays. I'll get to your table very, very soon to show you.
Make everybody know.
Sorry.
I talk am.
no be eyes dey pain us.
Video.
That's a signal.
Oh, camera by mouth. Ah, you bad you.
That's a signal. Is this your positive?
That's positive, yeah. Vibos.
You see no dey shock.
And then this is your negative, yes?
Yes.
Yeah.
My own touch light too. No pressure.
Okay, plug it in. It's plugged in.
Make I run the code.
Hold on.
As per backend.
This is positive, yes? All right, run your code.
Auntie, video, all camera on us. Auntie,
Run your code.
yeah, I told you, she has gone. She has gone. Are you ready? Okay, let me start. Run it. Yeah, Mark.
Wait, say please out now.
Okay.
Please out now.
Still zero. It's still zero.
Once you change this to 1,
It's still zero.
What's going on?
check your signal very well.
Clean it, but just
No.
It should change.
run.
Stop and run.
Let's check this. Wait, no, you're putting inside. Oh, yeah.
Still zero now.
Zero.
Yeah. Is it 1? Check your signal very well.
Check the connection.
Let me-
Nothing is wrong with the background.
Calm down. Check the connection well. What's going on? Check the place.
When there's no camera on us.
Is it still 0?
Zero for now. For now.
It's still not changing.
Stop and run.
That's supposed to run.
Stop it.
It was changing. It was changing.
Is this thing?
Nah.
No, it's not our own.
It was changing. When we were using our own, it was changing.
Hold on. Did you use the same pin for your delay and your? Hope you didn't use the same pin for your delay.
No.
It's 1, 3. And you don't choose to 1. No.
Is it?
Man, stop and
Wait,
run.
stop and run.
All right, hold on.
Okay,
What is your signal pin?
Signal pin.
Your water sensor.
Water center 2.
2.
And is it pinning?
Yes, pin in.
Yes. Man, I want touch light for you.
And your relay is pin out.
Yes, pin out.
And it's not pull up.
No pull up.
Supposed to work.
It was working before.
Oh, yeah, run.
All right, run it again.
Remove it and remove that.
1.
0.
Is this
0 1 0 1
0 1 0 1 0 1? Something is not connected. That's called floating state.
Let me stop again.
Something is not connected, bro.
Check the breadboard.
Something is not connected, bro. Let me quickly get another table and I'll come back to you guys.
No.
Just show them.
Waste time like that.
Just show them really working. They don't need to see the pump working. Just really that's all. They should be closing by now.
Okay. Sorry. Give me another. Okay. Hold on. Let me remove the. This is a positive, yes? Where's your negative? This is your negative. Then where's your signal? That is all right. All right, run your code. Let me see. All right, so
What's the other person now? Somebody should represent this group and think back.
okay, sir. That is on 1. That is 0. So once you see to go off again, then it will come on. To click again, you see that is relay. Now, usually, normally I'm supposed to display the pump for you. Please give me that pump and the battery.
The pump.
Okay, give me the pump and the battery. So, all right. So, you're supposed to this. Okay. So, this relay side, the other part of the relay has 3 ports. There is the normally open, the normally closed, and the common. It's all usually displayed by NO and NC.
Okay.
Which one is NC? Right? Okay, this is NC, this is NO. Normally open means, how many of you do physics here?
All of us.
Okay, if you look at your circuit, if you draw a circuit that gives you voltage and no ground, you know power is not supplied. That is your normally open. Your normally closed means your circuit is complete. There is voltage and ground. So now we are connecting it to our normally open and our common. So I will connect the positive of my pump to my normally open.
All right.
Or
The positive to the normally open.
the positive of the pump
To the normally open.
So normally open or common, either way. So I'm connecting this to the common. That is the middle side of the relay module. And then the positive side of my battery.
So maybe the remainder groups are going to check it tomorrow.
All right.
This is the positive side
Of my battery. All right. Okay, let me disconnect this guy. Then I'll connect the negative of my pump to the negative of my battery. That means anything that is happening on the controller side does not matter, because I have isolated. I have used the relay to isolate the connection. I have used the relay to isolate the connection. All right, plug it in. Select somebody in your group to return all the components. I'm sorry you could not show the relay for everybody. Tomorrow. Yes. Hello. Hello. It's not talking. I beg, let me tell them, say, groups, they don't see today, they see tomorrow. I beg. Today, I'll demonstrate for you tomorrow. Sorry, we don't have plenty. It's not working. Demonstrate for today. I'll demonstrate for you tomorrow. Sorry, we don't have many of voltage dependence with this, but tomorrow morning. Very much. Have a nice day. Please return back your. Yes, sir.